So right now we are going to look into a numerical problem where we are going to find out a 4-point DFT of a sequence x of n equal to 1, 2, 3, 4. So we are starting out with this question and I hope you can follow up. Okay, so we are supposed to convert a signal x of n into x of k using this DFT concept, or we are supposed to transform the signal from the time domain to frequency domain. Now we need to have an understanding of few things before moving ahead with the problem. So our basic question is find 4-point DFT, which means your DFT that you're finding out x of k should be having 4 samples. That is a hint provided in the question. When it is said 4-point DFT, it means that you have to find out the 4 samples out of the question that is given to you. So it will be given like x of 0, x of 1, x of 2 and x of 3. These are the 4 samples that you're supposed to determine for a 4-point DFT. If it was 5-point DFT, it would have been x of 4 to the additional side. Now this variable, we begin with the value 0 representing the position. For example, suppose if we draw the graph for x of n. So you know that this is a question given to you. X of n is 1, 2, 3, 4. So basically, otherwise if not hinted, basically you can assume that your signal sample start from the position 0. So at the 0th position you have the sample 1. At the first position you have the sample 2. At the second position you have the sample 3. And at the third position you have the sample 4. So this is the assumption that can be made regarding the signal x of n. So as given in the question, x of n is 1, 2, 3, 4, and this is the diagrammatic representation of x of n. Now before proceeding ahead, if you can remember the formula from the previous video of what is the x of k, it can be given by this particular formula, n equal to minus infinity to infinity, x of n e raised to minus j 2 pi nk by capital N. This is a formula for this particular problem to be executed. But before moving ahead, we need to have an idea about what is n, what is k, and what is capital N. So let me make it clear before moving ahead into the problem. So n typically would be representing the range of the position of samples in input signal. I repeat, n typically denotes the range of the position of samples in the input signal. K represents the range of positions of samples in output signal, or the x of k. Here meaning x of n and here meaning x of k. And capital N represents the total number of samples at output, desired output. So from the inference to the given question, we can understand that x of n I have already diagrammatically conveyed it to you. So you can understand that the position of n varies from 0 to 3. Now k, hence by the default, since it is periodic and since it will be identical over the 2 pi period, basically the idea conveyed is, earlier I had explained that your x of omega was continuous and periodic over the interval 2 pi, which means in this 2 pi interval we are actually trying to get 4 samples which will be starting from 0. So this can be represented as one sample, this as another, this as another, and this as another. So this makes up the 4 samples in this one particular duration of 2 pi. So their position 2 starts from 0, 1, 2 and 3. So the range of k can also be determined as 0 to 3. And what is capital N? Total number of samples at output. So as specified in the question, the expected number of samples at the output is 4. You need 4 samples, x of 0, x of 1, x of 2 and x of 3. So the total number of samples is n, which will be equal to 4. Okay. So now we have to start doing this question. So we can modify our equation as follows. X of k will be equal to, when we modify, the range of n can be converted from minus infinity to infinity because our sample space lies in the region of 0 to 3. So we can write it like n equal to 0 to 3 x of n e raised to minus j 2 pi n k by capital N. So here we have an assumption about what is n, what is k, and what is capital N. So we'll move ahead and do the problem. As already mentioned, this is the formula that we have obtained for implementing our particular problem. So we'll right now take up this opportunity to solve this particular problem, and will be, like I was mentioned in the previous slide, the first value that you need to find out is x of 0. So x of 0 is where k is equal to 0. So when we expand the summation, it becomes n equal to 0 to 3 x of n e raised to minus j 2 pi n, and since k is 0, this entire term becomes 0 by 4, since capital N is 4. So now this can be expanded as summation of n equal to 0 to 3 x of n. Why? Because this entire term becomes e raised to 0, which would be equal to 1. So this will become summation of n equal to 0 to 3 x of n. Now this can be written as sum of x of 0 when we expand it, x of 1, x of 2, and x of 3. So as you already know, x of 0 is 1, x of 1 is 2, x of 2 is 3, and x of 3 is 4. So capital X of 0 will be 10. So out of the 4 components, we have already obtained one of the values, x of 0, 10. This can be asked for a objective kind of question also. So by default, you can understand that because of this factor becoming 1, or this k becoming 0, hence e raised to term becoming 0, the first output of this particular DFT will be the sum of the input signals. This is something that you can take it for granted, and hence for objective test or any other short answer questions, you can definitely speedily find out the answer by just summing up the input samples of this particular DFT problem. Now let's look at the next case where you have to find out x of 1. So when it becomes x of 1, your expansion will be proceeding like this, n equal to 0 to 3 x of n e raised to minus j 2 pi n into 1 by 4. Why? Because k becomes 1. So this can be further written as summation and n equal to 0 to 3 x of n e raised to minus j. When 2 and 4 gets cancelled, this becomes 2. Now when you combine this entire term, it becomes n pi by 2. Okay. So now depending upon the value of n, this can go ahead. But before, or we'll do it in the next step. So as we move ahead, we can see that this becomes summation, or when we try to expand it. Let's now remove the summation or expand the entire series. So when we substitute n is equal to 0, this becomes x of 0. Now e raised to term becomes n pi. When n becomes 0, this entire term becomes 1. So it will be just x of 0 into 1. Okay, fine. And now moving ahead with x of 1 when n is 1. When n is 1, this term becomes 1 into pi by 2. So it becomes e raised to minus j pi by 2 plus x of 2 into e raised to minus j. When you substitute 2 over here, this 2 and 2 will get cancelled. So it becomes e raised to minus j pi plus x of 3 into e raised to minus j 3 pi by 2. So this will be the expansion of this particular series. And now before moving ahead, you need to know another one formula that is involved. So that will be basically regarding how to solve this particular e raised to minus j pi or minus j 3 pi by 2 sequence. So anything e raised in the form of e raised to minus j theta can be written as e cos theta minus I sine theta. I repeat, e raised to minus j theta can be written as cos theta minus I sin theta. So when we move ahead with this particular problem, when we try to solve it ahead, okay, so we have the cursor here. So x of 0 remains as such. This becomes x of 1 into cos pi by 2 minus I sin pi by 2 while it is in the bracket, plus x of 2 into cos pi minus I sin pi plus x of 3 into cos 3 pi by 2 minus I sin 3 pi by 2. I hope this expansion is clear. So this becomes x of 0 is 1 plus x of 1 is 2. Now cos sin pi by 2 is 1. Cos pi by 2 will be 0. So this will become 2 into minus I plus 3 into x of 2 is 3 and cos pi is minus 1. So sin pi is 0. So that term can be ignored. So it will become like this. Plus x of 3 is 4, and when x of 3 becomes 4, it becomes cos 3 pi by 2 is 0 minus I sin 3 pi by 2. Sin 3 pi by 2 is minus 1, so it becomes plus I. So you have the plus I term here. So when you go ahead, it becomes 1 plus minus 2I minus 3 plus 4I. So when you go for this particular solution, it becomes minus 2 plus 2I. So you get that particular answer, minus 2 plus 2I. So that would be this particular case for x of 1. So moving ahead with the instructions that have been already passed, you can determine x of 2 will be equal to minus 2 and x of 3 will be equal to minus 2 plus 2I. And hence your final answer should be written in this particular format. So we have already written x of k is x of 0, x of 1, x of 2, x of 3. So when we get the entire solution, we can write it as x of k is 10 minus 2 plus 2I minus 2 and minus 2 minus 2I. So this is the final answer for that particular problem, and you can spend your time in doing this particular program and find out the answer. So that covers up the DFT numerical part. So obviously you could get a question like somewhat in the format of in another way, where a question could come as find 5-point DFT of x of n, DFT of x of n, where x of n is equal to 2n plus 1, where 0 less than n less than or equal to 2. So these kind of questions can come where you will have to do a bit more application of the concepts, and you will have to find out what are the relevant values of n, k and n, and engage in finding out the solution. So I hope this basic concept of DFT numerical helps, and try doing the problem. Do some more problems of your own interest and find out the answer. You can do the problems from the reference text also and get a practice in this particular topic.